Hello everybody! In this lab, we'll observe the histology slide of urinary system. Objectives: identify the light microscopic structures of kidney, ureter, and urinary bladder. The first slide, kidney, obtained from the section of kidney, HE staining. The core test is covered by a layer of capsule made of dense connective tissue. Under microscope, many renal tubules with different sections can be seen in the core test, and the spherical renal capsule are dispersed among these tubules. The core test is mainly composed of the cortical lympharies and medullary rays. The cortical lympharies consist of the renal capsule and the convoluted portion of the renal tubules, proximal and distal convoluted tubules. Medullary rays are many bundles of tubules arranged in radiated orientation and consist mainly of the straight segment of the proximal and distal tubules, thin parts of the hyaline lobes and collecting tubules. For example, the arrow indicates the structure is proximal straight tubule. The third slide, kidney. The same slide. The renal capsule is a spherical capsule that consists of the renal capsule and glomerulus. The parental layer of the renal capsule is simple squamous epithelium that's easy to identify. The inner visceral layer of the renal capsule covered the central capillary tuft. The glomerulus, the nuclei of the endothelium cells, are ovoid, bulging into the capillary cavities, in which blood cells can be seen sometimes. The cells of the visceral layer are called pondocytes, the contours of which are indistinct under light microscope. It's difficult to separate them from the endothelial cells. The cavity between the parietal layer of the capsule and the glomerulus is capsular space. Examine the renal capsule on the slide carefully. Perhaps you can find a renal capsule connected with the proximal convoluted tubule at the urinary pole, or one connected with the afferent or afferent arteriole at the vascular pole. Look at the proximal convoluted tube. The apparent feature of these tubules is the deeply red-stained appearance. The tubule, always cut in the transverse and oblique section, have a rather thick wall and relatively small irregular lumen. The wall of these tubules are composed of a single layer of cuboidal or pyramidal cells with deep red cytoplasm. There is deep red stain, strip-like brush borders on their apical surface, and some longitudinal striations in their basal cytoplasm. Their nuclei are round, located in the basal portion. The boundaries between the cells aren't clear. Distal convoluted tubule is smaller in the diameter than the proximal convoluted tubule and has a large and relatively regular lumen. Its wall is composed of smaller, faintly stained cuboidal cells that have no brush border on their floor surface. The nuclei are round, located in the cell center. The boundaries between the cells are distinct. Look for the distal convoluted tubule next to the vascular pole of renal capsules carefully. Sometimes the distal tubule cells closest to the renal capsule change into columnar epithelial cells, arranged compactly and orderly. That's the medulla densa the arrow indicates. The medulla is chiefly composed of collecting tubules and the thin part of Helen's lobe. The straight segment of proximal and distal tubules are located in the superficial position near the cortex, often in the longitudinal section. The morphology of these cells resemble that of proximal and distal convoluted tubules respectively. The part of Helen's lobe always takes possession of the outer subcortical zone of the medulla, and is the thinnest portion of the renal tubule. Its wall is lined with a single layer of the fattened cell with ovoid nucleus. The cells are less flattened than of the capillary endothelium. Its cytoplasm is stained deeply. The collecting tubule is always located in deep zone of the medulla. It's thicker in diameter and centrally placed nucleus. The cell boundaries are distinct as the tubule goes forward to propeller. The diameter of the tubule becomes larger and larger. The height of the lining epithelial cell also becomes increased. The fifth slide, ureter, obtained from the section ureter HE staining. The wall is thick. It can be divided into 3 layers from inside to outside. The inner layer is the mucosa, that consists of transitional epithelium, and the lamella propria contained numerous fibers. Lumen is lined by urinary epithelium, which throws up into folds in the relaxed state. The upper 2/3 wall of the ureter contains 2 layers of smooth muscle, an inner longitudinal layer and an outer circular layer, and the lower 1/3 wall includes internal longitudinal middle circulatory layer, external longitudinal layers. Surrounding the muscular wall is loose connective tissue adventitia, contains plentiful blood vessels. The last slide, urinary bladder, obtained from the section of urinary bladder HE staining. The wall of the bladder is thick. It can be also divided 3 layers from inside to outside. The inner layer is the mucosa, that consists of transitional epithelium, and the lamella propria contained numerous fibers. The mucosa projects some irregular process into the cavity-forming folds. Compare the structure of the transitional epithelium when the urinary bladder is empty or full. When the bladder is full, the capacity of epithelial cells to slide upon one another reduces the thickness of the epithelium. As a result, the interior surface of the bladder increases. Okay, that's all for today. Thank you for your listening.